Hello everyone. In our last video, we had seen that what is circle, what all are the properties of circle, what is tangent, and what all are the properties of tangents. Now in this chapter, that is your area related to circles, we will be studying about area related to circles. Whatsoever the area is there which is related to circle, that we will be considering, we will be learning in this chapter. So let's start. Suppose we have taken a circle with center O and radius R. Here OA is the radius of the circle and that is denoted by small r. Now we know that the perimeter of any closed figure is, if we are going to start from a point and we go throughout the boundary, whatsoever the distance we cover is the perimeter of any closed figure. Now whenever we are talking about circle, instead of perimeter we use the term circumference. So circumference of the circle, that is we have learned in our previous classes even, it is your 2 pi r. 2 pi r is the circumference of the circle. That means suppose if we start from here, throughout the boundary if we will move, the distance covered will be equivalent to your 2 pi r, where pi is a constant and the value of pi is, either we take it as 22/7 or we take it as 3.14. This is the value of r. Pi, and r is the radius of the circle. Now the distance covered, that is circumference of the circle, will be 2 pi r. We have learnt already this in our previous classes. And the area of the circle is, it is given by the formula pi r square, where again pi is a constant and r is the radius of the circle. If it is the full circle, then this is the case. Now suppose instead of the full circle we are taking the half circle, that means we are taking the semicircle. In this case, suppose here again O is the center of the circle and R is the radius of the circle. So what will be the arc length? Arc length means, suppose this is your A and this is your B. So from here to here, this arc length will be half of the circumference, because circumference is the full distance covered. So if it is your half distance covered, it will be your half of your circumference, that is 2 pi r divided by 2, or we can say it will be your pi r. Now perimeter means, if we are going to start from here and again come back to this point, then it is your perimeter. So perimeter won't be only the arc length, it will include your AB length also. So perimeter will be, we can see it is the arc length plus your distance of A to B. We have seen over here that OB is the radius and OA is even the radius of the circle. That simply means it will be plus 2 times of R. R here, OB is R and OA is even R. So perimeter will be pi R plus 2R for a semicircle. Now the area of the semicircle will be half of the area of the whole circle. That will be your pi r square by 2 will be the area of semicircle. Now if instead of half, if it is 1/4, that is quadrant. If we are taking the quadrant of a circle, so it will be, suppose this point is your A, this point is B, O is the center of the circle and R is the radius of the circle. So the arc length over here we can see it is 1/4 of the arc length of the circle. So arc length will be, it is 1/4 of 2 pi r. 2 pi r divided by 4, that is pi r by 2 will be the arc length. Now again for the perimeter, OA will even be considered and OB will even be considered, and both are radius of the circle. So perimeter for the quadrant will be, it will be arc length, that is pi r by 2 plus 2 times of r. This will be the perimeter of this quadrant. Now if we will talk about the area, so area of this will be half of the area of the whole circle, that is pi r square by 4 will be the area of this quadrant. Hope it is clear what will be the perimeter, what will be the arc length, what will be the area for circle, for semicircle and for the quadrant. Now the another condition could be, suppose we are taking two concentric circles. Concentric circles we must be knowing that these are the circles with the same center. If the center of the two circle is same, this is the center for both the two circles, then such type of circles are known as concentric circles. For both these circles, the center is your O. Suppose for the inner or the smaller circle, radius is small r. This is O, suppose this point is A, and for the bigger circle, OB is the radius, and suppose it is denoted by capital R. So the distance, or you can say the area of this part, which we can say even ring also, the area of this part, how we can find it out? We can see from the figure, if from the whole area, that means area of the bigger circle, if we will be subtracting the area of the smaller circle, we will get the value of your area of this shaded part, right? So area of the bigger circle, because its radius is capital R, it will be pi r square, will be area of the bigger circle. For the smaller circle, area will be pi r square, that is your small r. Now, if we will be subtracting these two, we will be getting the area of the shaded part. That means the area of the shaded part will be pi r square minus pi small r square. Here we can see that pi could be taken common and it will be r square minus r square. So area of this ring could be found out using this formula, where again pi is a constant, r is the radius of the bigger circle and small r is the radius of the smaller circle. So this is how all these type of concepts will be used in this chapter for solving so many questions. We'll be seeing what sector is, what segment is, and how to find the areas of sectors, segments, arc length, all this in this chapter only. Now let's see what is arc length. Again, suppose we have taken a circle with the center O and the radius as small r. Here OB, OA and OB both are your radius of the circle. We can see over here that this is the smaller, if I am going to see the arc APB, obviously it is a smaller arc, that means it is your minor arc, and the arc your AQB, this is your major arc. The arc length is denoted by your small l. Now what will be the formula for finding arc length? It is given by theta over 360 multiplied by 2 pi r. It is the formula for finding arc length. Now let's see how we can find this formula. Over here we have taken for the minor arc that the endpoints of this minor arc is making an angle of theta at the center. Suppose this is the angle theta, which is formed by the minor arc your AB, endpoints of your AB. Now here we can see this angle is, if for the minor arc the angle is theta at the center, what will be the angle by the major arc at the center? We can find it out. We know that at a point the total angle is your complete angle is 360. If this whole angle is 360 and AOB, this angle is theta, so AQB, this your major arc will be forming at center O. The angle will be your major arc. The angle formed by this major arc, angle formed by major arc at center, it will be 360 degrees minus your theta. If the minor arc is making an angle of theta at the center, so major arc will be making an angle of 360 minus theta at the center, right? We know that. Now see, if the complete angle is theta, that is your complete angle is 360 degree, then we say that the total arc length is your 2 pi r. 2 pi r is the circumference of the circle, just now we had discussed. So if your angle is 360 degree, the arc length is given by 2 pi r. So by unitary method, we can find that what will be the arc length if angle is theta. So if the angle is 360 degree, the arc length was 2 pi r. So if the degree is 1, in that case arc length will be 2 pi r divided by 360. And if this degree is theta, the angle formed is theta, then yours it will be, if it is theta degree, so arc length will be theta over 360 multiplied by 2 pi r. So this is how we can get the arc length if central angle is theta. That means if the minor arc is forming an angle of theta at the center, we can find this minor arc, length of this minor arc that is arc length, which is denoted by small l using the formula theta over 360 multiplied by 2 pi r. Now suppose take an example that suppose if this is your radius is given to you as 7 centimeter. 7 centimeter is the radius of any circular part, any circular wheel, and angle at the center is your 60 degree. That means value of theta is 60 degree. Then what will be the length of AOBP? This whole length. We have to find it out. So we know that from here we can find the length of your arc length. Arc length we can find it out. What will be the arc length? Arc length will be given by theta over 360 multiplied by 2 pi r. That means value of theta is 60 degree over here. So 60 over 360 multiplied by 2. Pi we can take it as 22 by 7. We had discussed either 22 by 7 or we can take it as 3.14. If we have to take 3.14, it would be given in the question that use pi is equivalent to 3.14. Now value of r over here we have taken as 7. So this 7 are going to cancel. 60, 6 times it is going to cancel. 2, 3 times it is going to cancel. So it will be 22 by 3 will be the arc length, and if it is in centimeter, it will even be in the centimeter. Now see, only not the arc length is required. Required is your distance of BPAO. Means this is even required. OA and OB length is even required, and we know that these two are the radius of the circle. So required perimeter you can say it as, it will be 2 times of r plus your this arc length, that is 22 by 3. Or we can say r is 7 over here. So it will be 14 plus 22 by 3. If we will be solving it further, we will be getting the required length. 3 could be taken LCM. 42 plus 22. That will be 64 over 3. Or in decimals, we can find it out. So this is how we can use the formula for finding the arc length or for finding the perimeter either of the quadrant or for the semicircle, whatsoever is required. These type of questions are generally asked in 1 markers. In the objective type of questions, these type of questions are generally asked. Now let's see what is sector. So sector is the portion of the circular region which is enclosed by 2 radius and the corresponding arc. That means if we are going to consider a circle with center O, whose radius is a small r, that is OA, and OB are the radius of the circle, and theta is the angle made by the arc APB, that is your minor arc. If the angle formed is your theta, then your sector is area enclosed by these 2 radius, that is OA and OB, and the corresponding arc, that is your APB. That means this area is your sector. Whenever we are using the term sector or segment, we automatically means by default we take it as minor sector only. Whenever it is asked for the major sector, it will be specifically mentioned that use major sector. But if it is randomly it is said that use sector or your segment, that simply means we are talking about minor sector or the minor segment only. That means sector is the portion of the circular region which is bounded by 2 radius and the corresponding arc. That means this is the sector. The angle formed at the center is known as angle of sector. Again here we can see that the minor arc, this minor arc is forming an angle of theta at the center. That means the major arc will be making an angle of 360 degrees minus theta at the center. This will be the angle formed by the major arc at the center. Now see what will be the formula for finding area of this sector. It will be given by theta over 360 multiplied by pi r square. Again, by the unitary method we can find this value. If at the center we know that the total angle at the center is your 360 degree. If the angle is 360 degree, the area of the whole circle is given by pi r square. If the angle is 360 degree, total area is pi r square. If it will be 1 degree, we know it will be pi r square divided by 360. And if it is theta, angle formed by the your area formed by the angle theta, it will be theta over 360 multiplied by pi r square. So this is the formula by which we can find the area of the sector if the angle formed by it is your theta. If the angle formed is theta, then the area of the sector will be given by theta over 360 multiplied by pi r square. Now instead of this, if it is asked the area of the major sector, so there could be two methods. Either from the area of the whole circle, if we will be subtracting this area of the minor sector. This is your minor sector. So if you will be subtracting from the whole area, you will be subtracting the area of the minor sector, we will be getting the area of the major sector. This could be one of the method. Another method could be, instead of theta over here, we can take theta as 360 degrees minus theta. Suppose for here theta is 60 degree. For the minor sector, if the angle is your theta is 60 degree, so for the major arc, for the major sector, it will be 360 degree minus 60 degree. That will be 300 degrees. That means if we have to find the area of the major sector, then we will be taking theta as 300 degrees. This could be one of the method, and another method could be we can find the area of the whole circle. That will be your pi r square will be the area of the whole circle, and from the whole circle, if we will be subtracting area of the minor sector, that is your theta over 360 multiplied by pi r square, we will be getting area for the major sector. It will give us area of major sector. Either this could be the method, or we can say instead of theta we can take directly over here 360 minus theta over 360 into pi r square. Anyhow we can find it out, the area of the major sector. So what we had learned here is, if this is your minor sector and minor sector is at the center, this r, minor r is making an angle of theta at the center, then the area of this sector will be given by theta over 360 into pi r square. Because this minor sector is having a central angle of theta, so we can say that the major arc, your major sector, is forming an angle of 360 minus theta. And if this angle is 360 minus theta, so area of this major sector will be given by, either from the whole circle area we can subtract the area of the minor sector, or we can find the angle from here 360 minus theta, and instead of theta we can keep it as 360 minus theta over 360 into pi r square for getting area of your major sector. As we have done over here, similarly if we have to find the arc length of the major sector, arc length we have just learned that arc length is given by theta over 360 multiplied by 2 pi r. It is your for the minor arc only. If it is we have to find the length of the major arc, again the same thing we can do. Either from the whole length, that is 2 pi r, we can subtract this minor arc length, that is your theta over 360 into 2 pi r. This could be one of the method, or otherwise what we could do, instead of theta we can keep it as 360 minus theta for finding length of the major arc length. That will be, or we can say it as 360 minus theta over 360 into 2 pi r. By this method even we can find the arc length for the major arc, either by this method or by this method. Either from the whole circumference we will be subtracting for the your arc length of your minor arc, or we can take the theta as your 360 minus theta, that is angle formed at the center by the major arc. Now if we are going to see over here that this your arc length is given by small l, we had discussed earlier also, just now we have discussed that the arc length is given by small r. So if we are going to keep over here, this could even be written as one of the formula is this. Just now we have seen that for finding the area of the sector, this is the formula. Now if we are going to multiply this by 2 and divide it by 2, so this could even be written as, the numerator could be written as theta into 2 pi r into r over 360 into 2. Here we have taken theta, this 2 I have taken here, pi r square I have written as pi into r. In the denominator it is 360 into 2. Now see, arc length is given by 3 theta upon 360. theta upon 360 into 2 pi r into 2 pi r. This is the arc length. That simply means the area of the sector could even be written as, this is your arc length, which could be denoted by small l. This is 1 upon 2, so 1 upon 2 into L into R. This is even the formula for finding your area of the sector. This is the formula for finding the area of the sector. Along with that, we can even write 1 upon 2 into L into R. In terms of your arc length, even we can find the area of the sector. Now let's see what is segment. The portion of the circular region which is enclosed by a chord and the corresponding arc is known as segment. We have learned in our previous classes also. Here what we have taken is, again we have taken a circle with center O, and OA and OB is the radius of the circle. Here we have taken AB as one of the chord of the circle. Now the area enclosed by the chord and the corresponding arc, over here the arc is your APB is the arc. So area enclosed by the chord and the corresponding arc is known as segment. That means this is your minor segment. We can see we can analyze that this will be the minor segment, and this whole area which is remaining from here to here, this is your major segment. And this your chord, at the end point of this chord is making an angle of theta at the center. Again we can see if this is the angle theta, then angle formed at the major segment will be at the center of the major segment, it will be 360 minus theta. So if this chord is making an angle of theta at the center, at the major segment the angle formed at the center will be 360 minus theta. Here directly by seeing also we can see that it is very small in size, that's the reason it is minor segment, and this is very big in size, that's the reason it is major segment. But one more thing, by one more way we can say that this is minor segment and this is major segment. If your central angle is less than 180 degree, then we say it to be a minor segment, and if the angle at the center is more than 180 degree, we say it to be a major segment. Similarly for the sector also, in the case of sector, if the central angle is less than 180 degree, then it will be a minor sector, and if the angle at the center is more than 180 degree, then we say it to be a major sector. Similarly for the arc length, even we can say if the central angle is less than 180 degree, then it is your minor arc, and if the central angle is more than 180 degree, it is your major arc will be formed. So this is your minor segment and this is our major segment. If we have to find the area of this minor segment, just now we have seen that OAPB is a sector. Whenever we are saying sector, that simply means minor sector only, just now we discussed. So OAPB is a sector, and from this sector, if we will be subtracting the area of triangle OAB, we will be getting the area of the segment. So area of the segment could be written as, it is area of sector from this whole area OAPB. If we will be subtracting this portion, that is area of triangle OAB, then we will be getting area of the segment. Now area of the sector, we know how to find it out. The formula directly over here we can use is theta over 360 multiplied by pi r square. Just now we have learned that for the central angle theta, area of the sector is theta over 360 multiplied by pi r square. Now how we can get the area of this triangle OAB? Let's see. From here, from the center of the circle, if we will be drawing the perpendicular on the chord AB, suppose from here we have drawn a perpendicular on the chord AB. So we know that if from the center we are going to draw a perpendicular on the chord, it bisects the chord. That is the theorem we have learned in class 9th, I think. So from the center we have drawn a perpendicular on AB. Suppose it is meeting the chord at point C. So OC is the perpendicular and it bisects the angle even, central angle even, because these two triangles are basically congruent triangles. Why so? Because see over here in these two triangles, one triangle is your O OCB is one of the triangle and another triangle is OCA. In these two triangles, if we are going to see, then this angle C is 90 degree, means both the two triangles are right angle triangle. Here we can see that OA is equivalent to OB of triangle OCB. OB is equivalent to OA because both are radius of the same circle. Similarly, OC is common for both the two triangles. That's the reason we can say that these two triangles are congruent. If these two triangles are congruent, we have written that OCB triangle is congruent to triangle OCA, and if these two triangles are congruent, by CPCT we can say that AC will be equivalent to CB, although it is a property, but we can say along with that this angle will be equivalent to this angle and this angle will be equivalent to this angle. That means OC is the angle bisector. We have just now taken this whole angle as theta. If this whole angle is theta, that means half of this angle will be theta by 2. That means this angle will be theta by 2 and this angle will even be theta by 2. Now see, for finding the area of triangle we know that it is 1 upon 2 base into height is the formula for finding area of any triangle. For this triangle, we can see OC is the height and AB is the base. That means for finding the area of this triangle, we want the length AB and we want the length OC. If we can find the length either of AC or either of CB, we can find the length of AB because both are equal in length. We know that AC is equivalent to BC. Now, if we are going to consider any of these two triangles, suppose I am considering the triangle OCA. This triangle I am considering. In this triangle, we have seen that this angle is 90 degree, means it is a right angle triangle. This angle is your theta by 2. If this is the acute angle in this right angle triangle, so again we can use the concepts of trigonometry for finding the base and the height. How we can do that? Now see, this angle is theta by 2 and we are considering this angle. That simply means side opposite to this. That means AC will be the perpendicular over here. And your height, this is your OC is the base of this triangle. In the triangle OCA, we are considering angle theta by 2. Angle is your theta by 2. In this case, side opposite to this theta by 2, that is AC is the perpendicular and OC is the base. Now from here, we even know that OA is the radius of the circle and it is your hypotenuse. OA is the radius of the circle, that is R, and it is even the hypotenuse of the triangle. Now we know that sine theta is the ratio of perpendicular to hypotenuse. Sine theta over here, value of theta is theta by 2. So we will be taking sine theta by 2. It is equivalent to perpendicular. Perpendicular means your AC. AC is the perpendicular and your hypotenuse is radius that we have taken as R. Small r is the radius of the circle. Now from here we can say that AC is equivalent to R multiplied by sine theta by 2. Theta by 2 is half of the central angle and R is the radius of the circle. From here we have got the value of AC. Now again, if we are going to see over here, so we know that cos theta is equivalent to base upon hypotenuse. Over here theta is theta by 2, so we will be taking cos theta by 2. Base is here is OC. OC is the base, so it will be OC upon hypotenuse is your radius is the hypotenuse. So we can see that OC is equivalent to R multiplied by cos theta by 2. This is the value of OC. We know that the area of triangle OAB will be 1 upon 2 into base is your OC. OC is the base and height is your, AB is the base. This is AB is the base and height for this triangle is your OC. Now AB could even be written as 2 times of AC because length of AC and CB is equal. So we can write AB equivalent to 2 times of AC also and multiplied by OC. These 2 and 2 both are going to cancel. So it will be AC is, just now we have seen, AC is R sine theta by 2 and OC is R cos theta by 2. So if the central angle is theta, then the area of this triangle will be R into R will become R square sine theta by 2 cos theta by 2. This is the formula by which we can find the area of this triangle where theta is the central angle. This is the formula when we will be using when theta is more than 90 degree. When the case is theta is more than 90 degree, then we will be using this formula because we know in the chapter trigonometry that we are having the ratios, trigonometric ratios, we are having values of these trigonometric ratios at angle 0, 30 degree, 45 degree, 60 degree and 90 degree only. And if angle is more than 90 degree, so how we can find it out? In that case, we will be using this formula so that your angle, suppose it is 120 degree is the angle given in the question. So automatically 120 by 2 theta, that will turn to your 60 degree and we can easily find the value of R square sine 60 degree cos 60 degree. So if the angle theta, that the central angle is more than 90 degree, we will be using this formula. Now, what we will be doing if the angle is less than 90 degree? See, in the class 11th, you will come to know that sine 2 theta is 2 sine theta cos theta. Not up to 10th, but in the class 11th, we will become to know that sine 2 theta is 2 sine theta cos theta. Now see over here, if I am going to see sine theta by 2, cos theta by 2 over here. If I will multiply and divide this formula by 2, so it will become R square sine theta by 2 cos theta by 2 multiplied by 2 divided by 2, right? So 2 sine theta cos theta over here, just take it 2 sine theta cos theta. Over here theta is your theta by 2. So 2 multiplied by sine theta cos theta, we can write this as sine 2 theta. That means it could be written as sine 2 multiplied by theta by 2. That is, we can write this as sine theta. So the another formula for finding area of triangle OAB could be, it could be written as R square. This could be written as sine theta. So 1 by 2 into R square sine theta. This will be the formula we will be using when theta will be less than 90 degree. So what the formula will turn to, theta over 360 into pi r square is the area of the sector, and area of triangle OAB will be minus 1 upon 2 into r square sine theta. This will be area of the segment if your theta is less than 90 degree. Right? And if theta is more than 90 degree, so area of triangle we will be taking as r square sine theta by 2 cos theta by 2 will be the area of this triangle. That means we will be finding the area of the sector once. That is, formula for finding area of sector will be theta over 360 into pi r square, and then we need to subtract the area of this triangle from this, and area of triangle could be written as 1 upon 2 into r square sine theta, where theta is your central angle. This is the case when theta is less than 90 degree. And if theta is more than 90 degree, instead of this area of triangle, we can use the area of triangle as r square sine theta by 2 cos theta by 2. Hope it is clear. Now this is the area of your segment, that is your minor segment. Now again, if we have to find the area of the major segment, either we can take theta as 360 minus theta, or what we can do is from the whole area of the circle, that means from pi r square, if we will be subtracting area of this segment, we will be getting the area of the major segment. So we can say area of major segment, if we need to find, we can do is pi r square minus area of minor segment. By subtracting it, we can find the area of the major segment. Now let's see few more concepts used for solving questions. If we have to find a distance covered by circular object, say some circular object is rotating, say some vehicle is moving, distance it is covering, and we have to find how much distance the vehicle has covered. For that, what we will be doing is we will be simply finding the circumference of the circle. We will be finding circumference because circumference will give us the distance covered in one rotation. How much distance the wheel has covered in one rotation will be given by circumference of the circle, that is your 2 pi r. And if the number of rotations vehicle has made, that means wheel has made, suppose the wheel has made number of rotations is your number of rotation is say n. It could be 1000, it could be 2000, it could be 500, it could be 200, whatsoever the number is. So we have to find the distance covered by this wheel or by circular object in this much of revolutions and this much of rotations, that is n, and that distance covered will be n multiplied by 2 pi r. This will be the distance covered by the circular object. If the object has rotated n number of times, radius of the object is r, pi is again the constant. That means by 2 pi r we will be getting the distance covered in one rotation, and once we are having the distance covered in one rotation and we are having how many rotations the wheel has made or the object has made, we can find the total distance covered by the object, and that will be n multiplied by 2 pi r. Now, what will be the angle made by minute hand in 1 minute? Means we are having two hands, one is your minute hand, another is your hour hand in our clock. So see, the minute hand, if we know, minute hand is covering the whole circle, that is 360 degrees it is covering in 60 minutes. In 1 hour, the minute hand is covering the whole circle, that means 360 degrees is covered in 1 minute. Not in 1 minute, in 60 minutes. So in 60 minutes, in 1 hour, the minute hand is covering a degree of 360 degrees it is covering. So in 1 minute, how much degrees the angle will be formed? That will be 360 divided by 60, or we can say in 1 minute, minute hand is making an angle of 6 degrees. Because in 60 minutes or in 1 hour it is completing the whole round, that means it is covering an angle of 360 degrees. So we can say that in 1 minute the angle made by the minute hand will be on 6 degrees. These type of questions are asked. It could be your 5 minutes, it could be your 8 minutes. So if we know that in 1 minute it is making an angle of 6 degrees, so in 5 minutes it will be making an angle of 6 multiplied by 5, that is 30 degrees. So this is how we can solve some questions related to it. Now, if what will be the angle made by our hand in 1 minute, so just now we have seen how much angle is made by the minute hand. Now, if we are going to see the hour hand is completing one whole round in 12 hours. Once it is completing 12 hours, then it is covering the whole circle. That means in your 12 hours means 12 multiplied by 60 minutes. It is making an angle of 360 degree. One whole round it is covering in 12 hours, or we can write 12 hours as 12 multiplied by 60 minutes. So in this much of minutes it is making an angle of 360 degree. So in 1 minute how much angle it will be forming, and that will be 360 divided by 12 multiplied by 60. 60 6 times, 6 2 times, that means in 1 minute the hour hand is making an angle of half degree. 1 upon 2 degree is the angle formed by the hour hand in 1 minute. So these type of the concepts will be used in solving few questions. Hope the chapter is clear to you. You must have understood what arc length is, what is sector, what is segment, how to find areas related to it. Soon we will be coming with more videos with the questions related to this and many more chapters also. If you have not subscribed my channel yet, please do subscribe for more chapters related to it. Thank you.